Okay, so today we're going to be talking about another form of linear equation that's pretty useful and that you'll see a lot. So let me just recap the forms that we know already. We know standard form, okay, which is ax plus by equals c. And we also know slope-intercept form, which is y equals mx plus b. Now, slope-intercept form is super useful because it tells us our slope and our intercept, which helps us make graphs. And if we have a graph and we can find the slope and the intercept, we can make an equation like this. Okay, today we're going to be looking at graphs where maybe we don't have all the information. So if we look at this graph here, if we take a look at this graph here, I do have points along this line, like I have one there, I also have one up there. But one thing I noticed right away is that my intercept, even though I know it's right here where this point is, I don't really know what that point equals. So I don't know what it is exactly. I don't know the y-intercept. Okay? And because I don't know the y-intercept, it makes it harder to write an equation. But it's not impossible, it just makes it harder. So the first thing I'm going to do is I'm going to show you one way that you can write an equation if you don't know the y-intercept. And then I'm going to show you how you can actually use another form of equation, point-slope form, to write it. And it's a little bit easier than this first way I'm going to show you. Okay? So the first thing we want to do, regardless of whether we know what the intercept is we want to find our slope. So I have a point here, and I have a point here, and I'm just going to count. So up 2 and over 1, 2, 3, 4, 5, 6, 7. So right now I know my slope m is 2 over 7. Okay, so we did that. I'm going to write that here. M equals 2 over 7. The next thing we're going to do is we're going to use one point. We're also going to use the slope, and we're going to use slope-intercept form to solve for the exact y-intercept. So in this space here, I want you to write y equals mx plus b. That's the slope-intercept form. Rm is 2 over 7. And we're going to use one point from this graph. And if I'm looking at points from this graph, I usually want to use numbers that are smaller because they're easier to work with. So if I'm looking at this graph here, I might use this point right here, which is -2 and +2. So I'm going to come back over here, I'm going to write -2 and +2. And one of the things I'm going to remind myself of is that this is an x value and this is a y value. And both of these x and y's, if I plug them into this equation, will make the equation true. I know that because they're on the line, and that's what that means. Okay, so what I'm going to do is I'm going to use these three things and I'm going to plug them in to this equation. I'm going to show you how that helps me solve for b. So instead of writing y, I'm going to write the y value that I have here, which is 2. Instead of writing m, I'm going to write 2/7 because that's our slope. Instead of writing x, I'm going to write -2 because that's what we have in our point. And I'm going to leave b alone. So now I have this equation and my only variable is b. That means if I get b by itself, I can figure out what b is supposed to equal. So I'm going to multiply here. I have 2 equals -4 over 7ths plus b. To get rid of this -4 over 7ths, I'm going to add 4/7 to both sides. And I'm left with b equals 2 and 4/7. And this should be my y-intercept. So I know my y-intercept should be 0 and 2 and 4/7. And now I can write my final equation. So I'm going to write y equals, I know my slope is 2 over 7. And I know my intercept is now 2 and 4 over 7. And the last thing I want to do is I want to check, does this number make sense, 2 and 4 over 7? So 2 and 4 over 7 is a number between 2 and 3. And if I actually did the division right here of 4 and 7, I'd get 2.57. So yeah, it makes sense because 2.57 is between 2 and 3, and that's exactly where that point looks like it's laying.